Welcome to Modine Manufacturing Company's Lawrenceburg, Tennessee facility. Known as the Crossroads of Dixie, Lawrenceburg is centrally located approximately 180 miles east of Memphis, Tennessee, 80 miles south of Nashville, Tennessee, and 50 miles northwest of Huntsville, Alabama. The population of Lawrenceburg is approximately 14,000. The average annual temperature is 60 degrees. At Modine Lawrenceburg, our greatest asset is our people. 15% of our employees have been here over 25 years. The safety of our employees is a priority, and as such, it is an area of constant focus. This is reflected in the historically good safety record in Lawrenceburg. With the commitment of everyone at Lawrenceburg, we continue to strive for the elimination of all recordable accidents. Modine Lawrenceburg consists of 2 manufacturing sites. The first facility, known as LB1, was opened in 1979. This facility has 140,000 square feet dedicated to manufacturing. Over the years, there have been numerous additions and upgrades to this facility designed to support the business growth. LB1 is a vacuum braze facility. Our second site, LB2, is located directly across Remke Avenue. Production began in this building in 2010. LB2 has 210,000 square feet devoted to manufacturing. LB2 is a cab facility. In 1983, Modine Lawrenceburg began production of the extruded tube air-to-air charge air cooler. In 1995, we entered the engine cooling market with the aluminum donut oil cooler for the Ford SN95 Cobra engine. 1998 brought production of the layered cooler design with a fuel cooler for Molly. Also in '98, Lawrenceburg launched the first powertrain cooling module for Navistar's Escobedo, Mexico truck plant. 2001 saw the first high-volume production of the layered cooler for the Ford Powerstroke diesel engine. In 2006, a liquid charge air cooler for Navistar was launched. Tesla was added to the customer base in 2012 with the launch of a battery chiller. In addition, 2012 saw the launch of our highest volume product with the Sagefe oil cooler for the Chrysler Pentastar engine. Annual volume for this cooler has reached 1.3 million. 2013 introduced the aluminum intake oil cooler to our product mix. The key manufacturing processes used in the production of layered coolers are: auto stackers allow Modine to produce high-volume subcomponent assemblies efficiently. These key pieces of equipment improve throughput, reduce labor, and maximize our manufacturing footprint. Lawrenceburg currently has 2 auto stackers. Vacuum braze furnaces are integral to the production of engine cooling products. Lawrenceburg currently has 6 furnaces in production, with a 7th furnace slated for installation in January 2016. The last 3 vacuum furnaces purchased in Lawrenceburg are consistent with Modine's global design. This is similarly true of the brazing fixtures and profiles. Vacuum brazing has been a core technology in Lawrenceburg for 35 years. Automated test systems enable Modine to confidently test to tight customer specifications. These test systems check for critical requirements such as leaks and height and weight requirements. These testers have built-in features to ensure that all components are present prior to shipment, reducing our overall risk in the field. These test systems have flexibility to test multiple products and allow us to serialize and capture critical data for each individual unit. Robotic welding and machining is utilized on our LCAC products. This cell went into production in 2007. The CNC machining allows us to meet rigid customer tolerances on mounting features. Modine Lawrenceburg employs advanced measuring systems to verify the dimensional integrity of components and final products. We utilize DCC coordinate measuring machines and a manual roamer arm for precision measurement. In addition, we have a non-contact measuring system for components that require exceptionally precise measurements. This machine uses optics and laser technology to avoid deflection errors in measuring. We also have on-site pressure and burst testing capabilities at Lawrenceburg. This allows us to perform exploratory and validation work that enhances both process and product knowledge. In 2010, we began our move to becoming a scale facility. A long-term lease was signed in March of that year for 210,000 square feet in what was once warehouse space in the Murray, Ohio facility. Official ribbon cutting and open house was held in May 2010. In the same year, we began the consolidation of several Modine facilities into Lawrenceburg. The initial consolidation integrated the Harrodsburg facility, followed by Camdenton, and most recently McHenry. In 2010, Lawrenceburg began controlled atmospheric brazing and launched the Gohar. 2011 brought the tube and fin oil cooler from Camdenton. Additionally, we launched a 2-row CAC for Caterpillar. Concurrent with the Camdenton transfer, Lawrenceburg began production of bar plate product used primarily on John Deere combines. In 2013, we relaunched the Navistar ISX module used on the Cummins engine and brought Gohar side sheet production in-house. In 2014, the aluminum modular radiator was launched. CAT is the major customer for this product. In 2015, the lease of additional footage adjoining LB2 allowed us to eliminate our off-site warehouse. The Lawrenceburg campus continues to grow and define what it means to be a scale facility. Over the past 5 years, we have added over 100 new customers. We have a diverse customer base and ship to over 180 locations around the world. Our biggest growth opportunities lie in engine products and specialty vehicles. Throughout this transition period, Lawrenceburg has performed consistently. We are committed to continual improvement as we move towards the ideal state and improve the capability of our people. The foundation of this facility has been built upon our people and the flexibility that we offer our customers. As Lawrenceburg continues to develop into a scaled facility, we must combine the things that have made us successful with a relentless focus on robust processes that mitigate product risk in the marketplace, judicious use of capital, overhead reduction, and standardization of our systems.